So, today first I will be starting with fingerprint, then if time permits, then I will cover ear biometrics, and after that your quiz will be there, right. Now, so what are the advantages on your fingerprint? First one is the long tradition of using fingerprint in law and enforcement, right. That is that in any police case you will find that they have taken the fingerprints, they collect the fingerprints. You go to registration area, land record where you have given the fingerprints. The next one is the existence of large fingerprint database. This is also important thing, because if you have the large database, then you can test your system to find out what is your FAR and FRR. Am I right? Because that is the most important thing, that what we do otherwise. What I do otherwise, that if I have the small database, say 1000 size, then FAR finding FAR is basically you have 10 to the power 3 into 2, that is 6 size, whereas FRR for competition you have only the 1000 database size. But in the case of fingerprint, it is the large fingerprint database you have, but mostly from the criminal area. Then it is being used very much for quite some time, that on forensic investigations. The scanner cost is very small, very less, very easily available, and size is also very small. You can take it from one corner to another corner easily, and it is easy to collect the data. You can tell anybody that put your finger on the top of it, and then you can get the data immediately. But it has several disadvantages. First one is that it has poor public reputations. What it means, that it is related with the criminal. So, whatever database we have, that it is related with the criminal, and then you feel bad to make the study with that criminal data you are handling. So, you may not like. So, it has a very poor ID things, and then you have the social stigma, that most of us, we know how to sign. Now, if you tell that to give your fingerprint, the society feels, social stigma means the society feels that why shall I know how to sign, why shall I give my fingerprint, right. So, I am an educated person, I do not want to, I know how to sign, I do not like to give my fingerprints. There are people, they feel that by giving the fingerprint, I may lose lot of money, something like that. That fingerprint is very, I can sign on the blank paper, but I do not want to give my fingerprint on the plain paper. So, that type of stigma exists. Then large variation of the quality of fingerprints over the population, right. It depends on age. Then there are people, they put oily food on their hand, and then if you give the fingerprint, then it gives something, the data gets smudged. So, and it gives you the different types of fingerprints. Then there may be cut on the fingerprint, and so it depends on the occupation and lifestyle also, right. Now, how do you give the data? Data you will be giving on a scanner, you will be putting the fingerprint or finger on the scanner, and then depending upon the environment, you have to give the pressure on the scanner, and then the data will be collected. So, how you are giving the, how much pressure you are giving, what angle you are putting, all those will be coming in between. So, that is the reason you see there is a problem. You will find that the way you press the finger on the scanner, right, to provide it, that is there, it exists. And also there is a problem of cleanliness of the sensor, because if the sensor is not clean, the lot many noise may be there. That noise may create the extra minutiae points. And also there is a word of public hygiene. The public hygiene means that suppose I put potassium cyanide on my finger and I give the pressure, and then I leave the place, then the potassium cyanide powder will be on the top of the scanner, the next person will be putting his finger, and there is a possibility of havoc or creating the problems in the society. Next one is the non-availability of the fingerprint. There are 15% of the people in India itself, you will find that they do not have the fingerprints, right. The finger exists, but fingerprint does not exist because of the hard work and work style, right. Finally, there are people, they may not have the finger. Suppose I consider that ring finger is your finger from which you will be giving the data, and the concerned person may not have the ring finger, and so on. So, there are several disadvantages. Now, like any other biometric system, in the case of fingerprint, you have the following steps. First one is that you have to enhance the image, right, and from the enhanced image, you will be extracting the features. These features are the minutiae point, because our algorithm is based on the minutiae points, and finally matching. What are the enhancement technique? You given the fingerprint image, that is you have to convert, it is a grayscale image, you have to convert it into the binary image, and then you have to thin it. So, you get a thin means what? 1 pixel edge, and then you have to extract the minutiae. How to binarize? That is known to you, right. You will be, how are you going to do it? Tell me one method. Thresholding, right. You get one threshold, and then above some threshold, or first you obtain the histogram and see that is there any peak. Based on that, you decide this part will be considered as the 0, and other part will be considered as 255. Now, once you get the binary image, you will find that edges will be thick enough, right. Edges will be thick enough. This is a binary image, and edges will be thick enough. Now, this thickness is not constant. This is variable, but that will not help us. We need to make a constant width edges. So, thinning is required. How to obtain the thinning? It is an iterative process, because in one step you will not get it. So, you make a mask, say 3 cross 3 mask, and that mask you will be putting, you will be covering from one corner to another corner row wise. And if you get all ones, then you put the center is 1, other like that, or several ones, you put the central one, corner diagonal ones, then you put the center one, and so on. So, after a certain stage, you will find that there is no one replacement is coming, and so you will tell that the thin image you have obtained. Now, agreed, is clear? Yes. So, you got the thin image. Now, if you look at the thin image, there are several characteristics. I do not know whether you can see it or not. Here there is a point from where there are 2 edges are coming on. These edges are known as ridge, right. These are ridge, and inside thing is the valley. Here you can see that it has stopped here, right. So, ridge divided, this is known as end point, and this is bifurcation. In a fingerprint, you will find that there is a possibility of bifurcation, but trifurcation will not be there. Either ridge will be stopped at some point, this is known as regending, or you may find that it is continuous line. So, it is a continuous ridge point, and or you can find that it is a bifurcated one. Okay. So, these regending points or this point, these are bifurcated, they are considered as the minutiae points. Now, these points are represented by 3 factors. One is x coordinate, another one is y coordinate, and another one is the direction or angle, right. What angle it is coming this, or but if you moving this, whether it is what angle it is creating, that angle. Now, also we have another parameter which is known as type parameter, whether it is a bifurcation or end point. We will be considering one of the two. A minutiae point is either of the type of end point or the bifurcation, and it is at the coordinate x and y along with theta degree, right. So, this is an end point regending, and this is the bifurcation point. Now, how to extract the minutiae points? So, this will give you the basically a bifurcation scenario, or it need not be this direction, it may be this direction, that direction, whatever it is, but this will be a structure of your bifurcation. This will be a structure of your endpoint, right. This is a continuous one and so on, right. So, to find whether it is a continuous line or not, what we do? These are numbered as P1, P2, P3, P8, P9, P8, right, P1 to P8. So, let us consider it is P1, P2, P3, P4, P5, P6, P7, P8. Now, this Cn, this is known as crossing number. Cn can be computed by this formula 0.5 summation over Pi minus Pi plus 1. Why 0.5? Because the same number will be computed twice, that is the reason. So, for this case, this minus Pi plus 1. So, this is 1, this is 0, this is 0, this is 1, this is 1, this is 0, this is 0, this is 1, right. So, how many ones you are getting? 1, 2, 3, 4. Divided by 2, that is why 0.5, because I have considered, you observe that P1 has been taken into account, because it will be a combination of 0 or 1, and each line is only one, but it is a thin image. So, if this is 1, this is unlikely that this is an 1, but then if it is a 1, then this is a line basically, but ridges generally you do not get the ridge like that, this will be like this only. Okay. So, this is 1 plus 1 plus 1 plus 1, this 4 ones divided by 2, it gives you 2. That means, it is an even number. So, if it is an even number, then it is a continuous line. Similarly, you can, here it is, see, it is 1. This is 1 and rest of the thing is 0 and again 1, 1 plus 1, 2 divided by 2 is 1. Here you will find what? 3, right, 1, 1, 2, 1, 2, 3, 4, 5 and 6 divided by 2 is 3. So, this is, if it the sum of this is 3, then it is a bifurcation, if it is 1, then it is the end point, otherwise it is a continuous line. So, if it is a 0, then it is an isolated point. 0 means this all of them are 0, only one is lying, then it is an isolated point, right. If 1 it is a regending, 2 is a continuous ridge point and 3 is bifurcation. And what is crossing point? Crossing point is nothing but if it is like this. So, it will be a crossing point, right. So, this is 4. Now, for each, so we are interested for 1 and 3, and for each of them I have the x and y coordinate, then orientation and finally, the type. Type means, as I told you, it is a, whether it is a regending or it is a bifurcation or not. So, for suppose there are n minutiae points of any fingerprint, then this is M1 is a minutiae point, M2 is another minutiae point, Mn is another minutiae point. Mi is represented by a triple xi, yi and theta I and a type Ti. Right? This is a 4 triple xi, yi, theta I, Ti. Agreed? Now, these minutiae points is not extracting this minutiae point is not easy. One of you will be doing the how to extract the minutiae points, true minutiae points, right? Who is that? So, that is the one thing you remember, it is not that easy. Why I am telling you that it is not easy? Suppose there is a noise. Suppose there is a noise, and due to that noise, suppose this was the bifurcation point, and due to this noise, this is gone. So, you will be getting here one end point and here another end point, here another end point. 3 end points, also here also another end point, 4 end points you will be getting. And also this will be type 1, this is a type 1 you will be getting, because this is a regending, this is also regending. So, type 1 type minutiae points. Now, what I will be doing, I will get an minutiae points, I will first check whether these 2 minutiae points are having the same type or not. If they are same type, then only I will be finding the distance between these 2. If the type is not same, then I will not consider, right. Now, you observe here that if you consider this is a type 1 minutiae point here, another minutiae point here, right. How many minutiae points you got? 4 minutiae points. But if it was like this, then you got the 3 minutiae points, and here additional 1 additional minutiae points you got, agreed, and also that it is different type. So, you are not going to compare these 2. So, error will be introduced here. So, what you have to do, if you find there is a small distance between the say distance here is a very small distance. What do you mean by small distance? Maybe few pixels, 2 pixels, 3 pixels, then you before you obtain the minutiae points, you connect that. You connect that. That will give you the better or true estimate of your minutiae points, right. So, this is known as line fitting. You fit the line, and after that you obtain the minutiae points. Now, there is another problem you may face in that case. Suppose you have the like this, and there is a cut mark. There is a cut mark, cut, straight line. There are people you will find there is a cut. Generally, this cut is always straight line. A cut cannot be like this. This is almost near straight line. So, this is a cut mark, and you know this mark also will be considered as a minutiae point. This will also provide you the extra minutiae points. Here we make mistakes. This is not possible for you to determine whether this is a cut mark or not. If it is a cut mark, then you ignore it. Is it clear? So, we assume that there is no, in your limitation you can put that there is no cut mark, right. If there is no cut mark, you must be able to determine the all true minutiae point. That is our target. Rest of the things we will take care. So, once you know these minutiae points, any doubt at this stage? And I told you that how to define the minutiae points. See, here you observe there is a mark which is not here. So many minutiae points you can get, but generally it is expected that 30 minutiae points you should get at least. It will be there. Now, given 2 images, 2 fingerprint images, you get the set of minutiae points. Now, another minutiae point set is this, right. Now, you have to find out how many minutiae points are masked. So, one thing you remember, this n and this n prime may not be same. So, it may have n minutiae points, it may have n1 minutiae points, it can contain x or a true minutiae points, it can contain a true minutiae points and remaining n minus a false minutiae points. Also, there is a possibility that it may miss the b minus true minutiae points. A true minutiae points it has found, n minus a false minutiae points it has determined, and there may be b false minutiae points. Is it clear? Or b true minutiae points which are not detected by you. Here among this n1, it may get a dash true minutiae points and n1 minus a dash are the false minutiae points, and b dash minutiae points, true minutiae points it could not detect. That is a possibility, right. So, if this is your aim is to, his aim is to minimize this, his aim is to minimize this, right. But you know, if you minimize it, B will also increase. That is the issue. If you try to reduce this one, you will find that you are missing also several true minutiae points. So, you will be minimizing n minus a and maximizing a, that means minimizing b, which is difficult. That is the issue what we are looking for. Is it clear? So, let A and B are the two set of minutiae points extracted from the database and query image respectively, and you have the 4 triple to determine. Now, how to see whether it is matched or not? First, you obtain difference between, you have the x and y coordinates, so you find out the distance, right. One thing you remember, that if somebody's fingerprint is like this, another fingerprint will not be like this. This is not possible. Maybe 5 degree, 3 degree, 4 degree, 10 degree, it will not be more than that. So, first you find out the distance between the two coordinates x and y. X is the coordinate of xy is the coordinate of one minutiae point of the probe image, and x dash y dash is the coordinate of the minutiae point, coordinate of a minutiae point of another image. So, you can find out the distance, right, and if you find the distance is less than r0, some threshold value, you tell yes, these two minutiae points are matched, and you mark it 1, otherwise you mark it 0, right. So, what happens that you take one minutiae point, you find out among the, you take one minutiae points and you find a set of minutiae points, you find out the what is the best match, and that match if you find it is less than r0, you tell 1 and you remove both the minutiae point from your next search one. You take next minutiae points, again remaining minutiae points you have, you matched whether it is there exists or if it is there, and remove, and so on, right. Later on you will find what? That for one you will be finding n1 search, then second one n1 dash n dash minus 1, third one n dash minus 2, and so on. And now, how many of them are matched? You can find out if that number is less than threshold, then only you can tell yes, it is matched. So, that is the thing you are telling, that if it is less than this and also their angle also less than some threshold value, then you tell yes, that element has been matched, you go for the next one, and so. Why I am introducing this one? There is a possibility that one M1 is also matching, and you know you have one set like this and this is another set, this is M1, this mapping is there, that may also occur like this. Which one you are going to consider that matched, this one with this one or this one with this one? So, what we are doing, that we are checking also the angle. If angle is less than the threshold, you tell yes, not only the distance match, its angle also match, then you select that this is selected. So, both these elements will be removed from my search area. The next one I will take again I will find out whether there exists a closer one or not. If there exists closer one, then you check whether it is less than some threshold value with respect to the angle. If it is so, then accept, otherwise you throw them out also, and so on. Finally, how many ones are there, that you have to determine. If the one is number one is less than threshold value, you tell it is not matched. If it is exceeding some threshold value, you tell it is matched. Huh?
We are only considering the distance and the angle difference.
Yes.
Type is
Of course, type first you will be taking the same type. These are all within the same type. Type is the highest one. If they are not same type, then you are not going to, because unnecessarily why to do this. Now, in our case, we have tested against 1779, FAR is very high, FRR is moderately good, accuracy is 93%. What are the limitations? If it is aligned, improper alignment, then the system creates problem. Now, what do you mean by alignment? First one is that if my finger I put this way, or I put this way, or I put little tilted one, okay, then it will create problem. Or if its angle is too much, it will give you error. Poor quality image create problem in the location of minutiae. This is true, because the quality of image, suppose it is a smudged one, where is the bifurcation point? It is very difficult to determine, right. That ink pad or inked based fingerprint is the one example where it is very difficult to determine the minutiae points. Then there are some cases, I do not know whether some of you has raised that dry fingerprints, that if you have the thumb pad and you get the ink on your finger, and then you put it, and after some time you will find that some part is becoming dry, it is not visible, but some part is very good, right. So, that is also another problem, that from that if you try to improve or enhance the image, the other part, weight part also get enhanced, and if you remove something, then your dry part will go away. So, you have to compromise between these two. The reason belly structure of the image should be clearly separated, that is the smudged one. Sometimes because of ink, that it covers the belly part. Then because of weather, you may find that images are distorted. So, it is not possible to extract the minutiae points. So, aim is, your primary aim is to extract the minutiae points first efficiently. Once you can extract the minutiae points, you are through. Rest of the thing is very simple. So, his task is to, he will be giving me, are you going to give us that? Huh? Are you going to give us the true minutiae point now? You will be giving, right? Wow, very good. That is the thing I am looking for. And if you do it, I will be the happiest person. So, you know, how, if I am happy, then what? You are also happy. So, give it, and our test data is ready. That I will not give you. Okay? Any other query on fingerprint?